A single tablespoon of this plant contains more protein than an entire egg, grows faster than bamboo, and doesn't need dirt, fertilizer, or even much space. Sounds like something from a sci-fi movie, right? Except it's real. It's been around for billions of years, and you can grow it in your kitchen starting tomorrow. We're talking about spirulina. And if you think this is just another health food fad, stick around, because what this organism can do is legitimately wild. Let's get something straight right off the bat. Spirulina isn't actually a plant. It's cyanobacteria, which sounds way less appetizing, so everyone just calls it a blue-green algae. But here's the thing. This organism has been photosynthesizing on Earth for around 3.5 billion years. That's billion with a B. It was producing oxygen before there were trees, before there were animals, before there was basically anything else alive that you'd recognize. It's one of the oldest life forms on the planet, and it's been quietly doing its thing in warm alkaline lakes this entire time. Now you're probably wondering, why does this matter? Who cares how old it is? Here's why. That 3.5 billion years of evolution made spirulina absurdly efficient at converting sunlight and water into nutrients. It's had more time to perfect the process than basically any other organism. And the result is something that makes normal plants look like they're barely trying. The protein content is where this gets ridiculous. Spirulina is 60 to 70% protein by dry weight. Let me put that in perspective for you. Beef is about 26% protein. Chicken is around 31%. Spirulina is more than double any of them. About 7 grams of dried spirulina powder contains roughly 4 grams of protein. That's the same amount of protein as an egg, but in a fraction of the volume. And here's the kicker. It's a complete protein. That means it contains all 9 essential amino acids that your body can't make on its own. Most plant-based proteins are incomplete. They're missing 1 or more essential amino acids, which is why vegetarians and vegans have to combine different protein sources. Spirulina doesn't have that problem. It's got everything your body needs in one package. But we're just getting started. The protein is impressive, sure, but spirulina is basically a multivitamin that grows itself. It's loaded with B vitamins, especially B12, which is notoriously hard to get from plant sources. It's got iron, more than spinach by weight. It's got gamma-linolenic acid, an omega-6 fatty acid that most people don't get enough of. It's packed with antioxidants, particularly phycocyanin, which gives it that blue-green color and has some legitimately interesting health properties we'll get into later. The nutrient density is so high that NASA has studied spirulina as a potential food source for long-duration space missions. When you're trying to keep astronauts alive on a trip to Mars, and every ounce of cargo costs thousands of dollars to launch, you want the most nutrition per pound possible. Spirulina fits that bill better than almost anything else. The European Space Agency has looked at it too. So has the Japanese space program. This isn't fringe science. This is serious research by actual rocket scientists. Now let's talk about how this thing grows, because this is where it gets really interesting for anyone who's ever tried to grow their own food. Spirulina doesn't need soil at all. It grows in water, but not just any water. It needs alkaline water, pH around 8 to 11. For comparison, normal water is pH 7. Pool water is usually pH 7.5. We're talking significantly more alkaline than that. Spirulina grows in places like Lake Texcoco in Mexico, Lake Kasserolm in Chad, and various lakes in East Africa. These are warm, shallow, alkaline lakes where most other organisms can't survive. The high pH kills off competitors and predators, which means spirulina has the whole lake to itself. It forms massive blooms, turning the water dark green. Local populations have been harvesting and eating it for centuries. They'd skim it off the surface, dry it, and use it as a food source. But here's the game changer. You can recreate those conditions at home. You don't need a lake. You don't need acres of land. You can grow spirulina in a tank, a tub, even large jars if you're just experimenting. People grow it in their garages, on their patios, in their spare rooms. The setup is surprisingly simple, though there's definitely a learning curve. The basic requirements are water, the right pH, warmth, light, and nutrients. Let's break that down. Water is easy. You can use tap water in most places, though you'll want to let chlorine evaporate first if your city chlorinates the water supply. Just fill your container and let it sit for 24 hours. The chlorine gas dissipates on its own. The pH is where it gets specific. You need to get that water up to pH 8 to 11. The most common way to do this is with baking soda, sodium bicarbonate. You add it to the water until you hit the right pH. You'll need a pH testing kit, the kind you can get at any aquarium store or online for $10. You test, you adjust, you test again. The pH stays relatively stable, though you'll want to check it regularly. Temperature matters. Spirulina likes it warm, between 77 and 95 degrees Fahrenheit. Room temperature works in many places, especially in summer. In cooler climates, or during winter, you might need a heater. Aquarium heaters work great for this. You're basically creating a very specific artificial environment, which sounds complicated but really isn't once you get the hang of it. Light is critical because spirulina photosynthesizes. It needs light to grow. Natural sunlight works if you've got a good spot, but direct sun can actually overheat small setups. Many people use artificial light, LED grow lights specifically. You want about 12 to 16 hours of light per day. More light generally means faster growth. Up to a point. Too much and you start having problems with overheating and pH swings. Nutrients are the final piece. Spirulina needs nitrogen, phosphorus, potassium, and trace minerals. You can buy pre-made spirulina growth medium online. Companies sell packets of powdered nutrients specifically formulated for growing spirulina at home. You mix it with your alkaline water according to the instructions, and you're good to go. Some hardcore growers make their own nutrient mixes, but that's getting into advanced territory. Once you've got all that set up, you add your spirulina culture. You can buy starter cultures online from various suppliers. It usually arrives as a liquid, already growing, just at low density. You pour it into your prepared medium, and from there, it's just a matter of keeping conditions stable and waiting for it to multiply. And multiply it does. Under ideal conditions, spirulina can double its mass every 2 to 5 days. That growth rate is insane compared to regular plants. Lettuce takes 30 to 45 days from seed to harvest. Tomatoes take 60 to 85 days. Spirulina, you can be harvesting in a week or two after starting your culture. The ongoing harvest is what makes it really interesting. You don't grow it, harvest it all and start over. You harvest a portion, maybe 20 to 30%, and the remaining spirulina just keeps growing to replace what you took. Harvesting is straightforward but takes some work. You pour the culture through a fine mesh cloth or a dedicated filter. The spirulina gets caught in the mesh. The water passes through. You're left with a dark green paste that looks kind of like, well, pond scum. Because that's basically what it is. You rinse it with fresh water to remove any salts or impurities. Then you press it to remove excess moisture. At this point, you can use it fresh. Some people add it directly to smoothies, soups, whatever. It has a strong taste though. Not everyone loves it. Most people dry it for storage. You can spread it thin on trays and air dry it, though that takes a while. You can use a dehydrator, which is faster and more reliable. Some people even use their oven on the lowest setting. Once it's dry, it crumbles into a powder that you can store in jars for months. The yield depends on your setup size and how optimized your conditions are. A small home setup, maybe 10 gallons of culture, can produce around 50 to 100 grams of dry spirulina per week once it's established. That might not sound like much, but remember, you only need a tablespoon or two per day for a significant protein boost. That 50 grams is roughly 7 tablespoons. One person's supply for a week from just 10 gallons of water. Scale that up, and the numbers get really interesting. Ooh! Commercial spirulina farms use massive open raceway ponds, sometimes acres in size, in places with warm climates and lots of sun. These operations can produce tons of spirulina per acre per year. Compare that to conventional agriculture. An acre of soybeans produces around 1,800 pounds of protein per year. And spirulina doesn't need fertile soil. It doesn't need pesticides because the alkaline pH keeps pests away. It doesn't need herbicides because other plants can't grow in that pH. The water is recycled. You're not irrigating and watching water drain away. You top off evaporation and replace water. You remove during harvest, but that's it. The environmental footprint compared to conventional protein sources is remarkably small. This is why organizations looking at food security and sustainability get excited about spirulina. You can grow it in places where traditional agriculture is difficult or impossible. Desert regions with lots of sun but no soil. Urban areas where land is expensive but rooftops or warehouses could hold tanks. Even in developing countries where malnutrition is a problem, spirulina offers a way to produce high-quality protein without needing acres of farmland. There's a project in Burkina Faso, for example, that's been producing spirulina to combat malnutrition. The organization builds simple spirulina production facilities using local materials. The spirulina gets mixed into food for children suffering from severe acute malnutrition. The results have been impressive. Kids gain weight faster, recover quicker. But let's get back to the home-growing side of things, because that's probably what most of you are interested in. Growing spirulina at home isn't quite as simple as growing basil on your windowsill, but it's definitely doable with a bit of effort. The main challenges are maintaining the right pH, keeping the temperature stable, and preventing contamination. pH can drift over time. As spirulina grows and photosynthesizes, it absorbs carbon dioxide from the air, which can affect pH. You'll need to test regularly and adjust as needed. Some people check daily when they're starting out, then less frequently once they've got a feel for their system's behavior. If pH drops too low, spirulina growth slows down and other organisms might start competing with it. Temperature stability is easier in some climates than others. If you're in a place where it's warm year-round, great. If you're somewhere with cold winters, you'll need to bring your setup indoors or provide heating. The good news is spirulina doesn't need a huge amount of space. A 10-gallon setup fits easily on a shelf or table. You can grow it in a spare bathroom, a laundry room, wherever you've got space and can control conditions. Contamination is the other concern. You're creating an environment that's perfect for spirulina, but sometimes other organisms can get in. The most common issue is other types of algae. Green algae can sometimes establish itself in a spirulina culture, especially if conditions drift away from optimal. The high pH is your main defense. Most contaminants can't tolerate pH above 10, or if you introduce contamination through dirty equipment, you can have problems. The good news is, you can usually tell when something's wrong. Healthy spirulina culture is dark green, almost blue-green, and has a distinct smell. Not a bad smell, but earthy and specific. If it starts looking different, turning bright green or smelling off, that's a sign something's wrong. Often the fix is simple. Check pH, adjust if needed, and maybe restart with a fresh culture if contamination is severe. There are online communities dedicated to home spirulina cultivation. Facebook groups, subreddit communities. People share tips, troubleshoot problems, post pictures of their setups. The knowledge base is surprisingly deep. If you run into an issue, chances are someone else has dealt with it and can tell you how to fix it. Now let's talk about the health claims around spirulina, because there are a lot of them, and they range from solidly scientifically supported to wildly speculative. The protein and nutrient content is undeniable. You can look up the USDA nutrient database and see the exact breakdown. But spirulina also gets marketed as a superfood that can cure everything from allergies to cancer. And that's where we need to pump the brakes a bit. There is legitimate scientific research on spirulina's health effects. Studies have shown that phycocyan, that blue pigment, has antioxidant and anti-inflammatory properties. It's been studied for its effects on cholesterol levels, with some research suggesting it can lower LDL cholesterol and triglycerides. There's research on its effects on blood pressure, on blood sugar control, on immune function. Some of this research is promising. But here's the thing about nutrition research. It's really hard to do well. Most studies on spirulina have been small, short-term, and sometimes poorly controlled. The results are interesting enough to warrant further study, but they're not definitive proof that spirulina cures anything. If someone's telling you spirulina will definitely cure your diabetes or prevent cancer, they're overselling what the research actually shows. What we can say with confidence is that spirulina is a nutrient-dense food source. If your diet is lacking in protein, B vitamins, iron, or antioxidants, adding spirulina will help address those deficiencies. For people eating plant-based diets, it's a convenient source of complete protein and B12, both of which can be challenging to get from purely plant sources. For anyone looking to increase their nutrient intake without adding a lot of calories, spirulina is effective because it's so nutrient-dense. The taste is the main barrier for most people. If we're being honest, spirulina tastes like pond water. Again, that's what it is. Some people genuinely don't mind it. Others find it unpleasant. The powder is easier to incorporate than fresh spirulina because you can hide it in smoothies, mix it into energy balls, stir it into soups. A tablespoon in a fruit smoothie gets masked pretty well by the other flavors. But if you try to just mix it with water and drink it straight, you're going to have a bad time. There are spirulina tablets and capsules available commercially if you want the nutrients without the taste. But if you're growing it yourself, the whole point is usually to have a fresh, cheap source. Drying it into powder and then encapsulating it yourself is possible but adds a lot of extra work. Most home growers just learn to incorporate the powder into their food in ways that make the taste tolerable. One creative use I've seen is adding spirulina to pasta dough. It turns the pasta blue-green, which looks weird but actually tastes fine, because the spirulina flavor is diluted by the pasta. People add it to homemade crackers, bread, even baked goods, though heat can destroy some of the nutrients. Fresh is always going to retain more nutrition than cooked. The cost savings of growing your own spirulina are significant once you're past the initial setup. Commercial spirulina powder costs anywhere from $30 to $60 per pound, depending on where you buy it, and the quality. If you're using a tablespoon per day, which is 7 grams, a pound lasts you about 65 days. So you're spending $30 to $60 every couple months. Compare that to home production. Your initial investment is maybe $100 to $200 for a basic setup. Tank, or containers, pH testing kit, nutrients, heater if needed, lights if needed, starter culture. After that, your ongoing costs are minimal. You're buying nutrients periodically, maybe $20 to $30 every few months depending on how much you're producing. Electricity for lights and heater if you use them, but that's usually a few dollars per month at most. Once your system is running, you're producing spirulina for a fraction of what you'd pay commercially. And there's something satisfying about growing your own food. Even if that food is technically bacteria, you're controlling the entire process. You know exactly what went into it. No pesticides, no mystery ingredients, no concerns about contamination during processing. It's as pure as you can get. The learning curve is real though. Most people who try growing spirulina at home struggle at first. Presage problems, contamination, cultures that won't grow, cultures that die off mysteriously. It takes time to develop a feel for what your system needs. But once you dial it in, it becomes almost automatic. You check pH once a week, harvest when the culture looks thick enough, add nutrients when needed. It's less maintenance than most houseplants once it's established. There's also something to be said for the resilience aspect of growing spirulina. If you're someone who's interested in food security, in being less dependent on grocery stores and supply chains, spirulina is a tool worth having. It grows fast, it's incredibly nutritious, and it doesn't depend on the growing season or weather conditions. You can grow it year-round in a controlled indoor environment. During the COVID pandemic, there was a surge of interest in home spirulina cultivation. People were stuck at home, worried about food access, and looking for productive projects. Spirulina fit the bill. The online communities grew significantly. Suppliers of starter cultures and equipment sold out regularly. A lot of people who started growing spirulina during lockdowns are still growing it now because they found it worthwhile. The commercial spirulina industry is interesting too. Most of the spirulina sold in stores comes from large-scale operations in places like Hawaii, California, India, and China. Hawaii spirulina, particularly from the company Cyanotech on the Big Island, is considered some of the highest quality because of the pristine growing conditions. It's also more expensive. Chinese spirulina is cheaper but sometimes raises concerns about contamination or quality control. The industry is growing. More companies are getting into spirulina production because the demand keeps increasing. It's not just health food stores anymore. You can find spirulina in regular grocery stores. Vegans use it for B12 and complete protein. People just interested in nutrition use it as a general supplement. There's also research into using spirulina as animal feed, particularly in aquaculture. Fish farming is a growing industry, and feed is one of the major costs. Spirulina grows in water. Fish eat it naturally in the wild, and it's nutritionally excellent. Some fish farms are experimenting with on-site spirulina production to supplement their feed. It's a closed-loop system. The fish waste can actually be used to provide nutrients for the spirulina, which then feeds back to the fish. The versatility of spirulina keeps surprising people. It's food. It's medicine. It's a dye you can use for coloring. That blue-green pigment, phycocyanin, is used as a natural food coloring in some products. It's being researched for use in cosmetics. There are studies looking at spirulina as a biofuel precursor, though that's still very early stage. This organism that's been around for billions of years keeps finding new applications in modern technology. For anyone interested in actually trying to grow spirulina at home, here's the practical advice. Start small. Don't invest in a huge setup right away. Get a 5 or 10-gallon container. Get a starter culture. Follow the basic instructions. Expect to make mistakes. Expect your first batch to maybe not work out. That's normal. Learn from it. Adjust. Try again. Join an online community where you can ask questions. And be patient. It takes a few weeks to get a system running smoothly. The payoff is worth it though. Once you've got a healthy culture producing spirulina consistently, you have a nearly infinite supply of one of the most nutritious foods on the planet, growing in your home requiring minimal space and effort. That's pretty remarkable when you think about it. Thanks for watching. If you want more content about unusual plants and growing techniques, subscribe. There's always something interesting to explore in the world of plants and food production.